Today we're going to consider definite integrals in relation to calculating the area bound between the curve and the x-axis and between some terminals A and B. So pretty much what integration can do is it can work out the area bound between the curves. So let me just draw a straight line in this particular instance. Now if I'm working out the area between the curve and the x-axis at this terminal, let's call this terminal B, it's going to calculate all of this area if I was to follow the integration and integrate between 0 and B. Now you'll remember when we calculate definite integrals, we actually subtract this terminal away from that terminal once we've substituted that into the integral. Well, this is why, look, see, if I put another terminal in A and that up to that point calculates the area of the curve bound by from the curve to the x-axis, I actually get all of this area. And if I do this whole area, subtract this area, I'm left with this area between the terminals of A and B. Now that's not to say the definite integral is the same, because it's not. The definite integral is the same as the signed area, which we'll talk about in a later video. This one, we're just considering the actual area, and we're going to be looking at just those above the x-axis at this point. So let's have a look at doing some calculations. I want to work out the area between the curve and the x-axis between, let's go, 1 and 3. Okay, now I've got the function, let's go, y equals x squared. Alright, so I want to work out this area here. So what I need to do is set up the integral sign. So I've got the integral between 1 and 3. So we start at the bottom and we go to the top, reading from left to right, of the function that we want to integrate, which is x squared with respect to x. And then we proceed and we follow exactly what I've just shown you up here, which is the fundamental theorem of calculus. So let's substitute, first of all, let's integrate, of course, x cubed over 3. And remember, we don't need to include that c when it's not a indefinite integral. So I've got 3 as my first terminal that I'm going to substitute in. So let's do that. I get 3 cubed over 3. And then we take away, sub the terminal 1 in, and we get 1 cubed over 3, which leaves me with 27 over 3, which is 9. Take away 1/3, so that leaves me with 8 2/3. Okay, now what we've got now is an area, so I can say that 8 2/3 units squared or squared units. And I can see, looking at the screen, that that's actually just gone off the bottom of my video. So I actually worked out that and written it down. So let's have a look at what happens when I use a little bit more of a complicated integral. So I'm going to calculate the area now between 0 and 2 of the curve bounded by the curve in the x-axis between 0 and 2. So I'm looking at the curve 4 minus x squared. So we set up the integral first. I'm going from 0 to 2. 0 to 2, that's the function I need to integrate with respect to x, and we'll start going ahead and integrating. So 4 integrated becomes 4x, and then the minus the x squared, we get minus x cubed over 3. Between 0 and 2. And then fundamental theorem says we substitute in 2 first, then we substitute 0 and subtract. So let's do that. 4 times 2 minus 2 cubed over 3. That's subbing 2 in. Now let's put 0 in, take away, and I'm going to go off the end of the screen here, but when I put 0 in, let's just have a look. 4 times 0 is 0, minus 0 cubed over 3, which is 0. So I'm actually going to end up subtracting the 0. See that? Now let's work out what we've got. We've got 4 times 2, which is 8, take away 2 cubed, which is 8 over 3. Converting that into a fraction, 8 becomes 24 over 3, minus 8 over 3, leaves me with 16 over 3. Okay, or you could say 3 whole and 1/3. Now, that pretty much tells you how to work out the area bound between the curve and the x-axis and 2 terminals. That's pretty much everything you need to know about working out the area above the x-axis.